It's question 8. I'm already sketched vectors A, B at the diagram. They ask you to sketch or draw the vector negative 2a, and you probably can take your ruler and do this and draw a segment, a longer segment, extend AC, and you get something like this. Must be parallel to AC, and then you can then repeat this, but now crossing point B, something like this, right? And then you try to draw another one, a segment like this. This segment right now should be parallel to segment AB, and then you go on and draw this segment, horizontal one should be parallel to BC, and then you should end this drawing like this, another segment again should be parallel to AB, and finally this point here would be a point D, and this one would be your negative 2a, right? And then let me solve part B first, because since I'm drawing this, okay. So this is the vector B minus 2a, okay, this one. And you should also mention this perpendicular, because this is the part where they ask you to show here. Just remember there's two ideas, two concepts. Number one, although A, B are not the same vectors, but they have the same magnitude. The other one is the interior angle of this equilateral triangle is pi over 3. So that's why you expanding this, perform the substitution, use the cosine formula for dot product and so on, and that's why it's 0. Okay, moving on to this one, quite the interesting questions right here. It's obviously the statement 3 is true, and why there's a case, because there are probably two responses. You could say that the sum of two sides of a triangle is greater than the other one, the third one, or you can use Pythagoras. You can look at this and think why this is true. Okay, and then in part B it's very interesting. They ask you to guess, actually not guess, you do know that this is actually the diagram that you should copy. And what's the justification? So of course we're looking actually the triangle ABC. I remember that the triangle ABC, and so by Pythagoras we know that a squared b squared equal to c squared, and so replacing a squared with EF and FD and then D for c squared, you get this, and therefore you know this must be the diagram. And moving on to the next one, right here, very interesting again. And here to justify your answer, here I can use cosine rule, and the angle theta, which is the angle ACB, is acute. When it's acute, then it implies that cosine theta is positive. And so right here, this particular expression, c squared plus 2ab cosine theta must be greater than c squared. Two things you need to grasp. Number one, you know, two positive numbers add up together must be greater than just one of it. And also the other thing is that ABC, they are all positive value. So, okay, and so you just again substitute the a squared, b squared, and c squared, you get this inequality. And the last one, you have no choice, you're only left with this diagram, must be this is the case. And the justification right now is because the cosine theta is negative due to the reason that theta now is obtuse. You think about why this is true, and okay, you should be able to solve this. The next one is a common mistake. A lot of students actually, even in the final last year, they made this mistake. And so the center, you know, if you rewrite this this form, you should be able to see the center is negative 1, 0, and the radius is 1 over 4, not half. Okay, and then I'll work on this one first, part C. Okay, and you show some steps, because they know that you're going to use a calculator. I think I missed this here, c square. Okay, and then show a little bit, and then calculation, and plot them. Z1, Z3 are the same. Z2 is somewhere here. C is actually in fact inside the circle. Okay, and move on to one more right here. And this one, I'm just going to do a little bit of working here. You just use a calculator. You can use a program, but you can just use a calculator. Sometimes it is actually faster. Start with this, and then the first iteration is this one, so I copy this here. Second iteration, third, fourth, fifth, and you can go on, and you can kind of count inside your heart until about 100 or 150. But here I stop at 100, and I got this, and so I use 100, this Z100, and got 3.16. And obviously you can see if you look at this later, you'll find that this is actually a two-cycle behavior displaying two-cycle behavior here. So I'm going to do the other questions later in other videos, and all the best.